Two properties of algebra with cross products. As we have noted, the cross product is not commutative, it is anti-commutative, meaning A cross B equals the opposite of B cross A. Furthermore, the cross product is distributive. I haven't proved this, but I think you can see from this diagram that this is true. A crossed with the sum, B plus C, is equal to what we would get if we distributed A to those two terms. So it's equal to A cross B plus A cross C. So this sort of can play the role of an informal geometric proof here. It does work even in 3D. If you imagine that A and B lie in the plane of the page, and that C and therefore B plus C are kind of angled out of the page, then it's possible to notice that the distributive property still does hold. I'll leave that up to you. But now let's try some example problems. Here are two vectors A and B and two vectors C and D, and I want you to find their cross products. Determine the magnitude and direction of these two cross products. Take a moment to do that. Pause the video now. Work out magnitude and direction of those two cross products. Ready? Okay. A cross B. A cross B will have a magnitude given by the magnitude of A, which is 6, times the magnitude of B, which is 4, times the sine of the angle between them, 120 degrees. And the direction is given by the right-hand rule. So A cross B, fingertips in the direction of A, palm towards B, curl in the direction of B, and my thumb is pointing straight out of the page. So we'll call that the k-hat direction. So we add in our direction here at the end, k-hat. This value works out to be about 20.8. So we'll say that A cross B is a new vector that points in the k-hat direction and has a magnitude of about 20.8. Okay, if you need to rethink your C cross D, do so now. Answer is C cross D. Our new vector has a magnitude given by the magnitude of C times the magnitude of D times the sine of the angle between them. Sine of 90 is just 1. And the direction. Okay, right hand, fingertips with C, palm towards D, curl fingers C towards D, and your thumb points directly into the page in the negative k-hat direction. So that result is negative 24 k-hat. Okay. Next up, some examples for you. Here we've got unit vectors being crossed with each other. When you've got cross products involved in an algebraic expression like this, you have to be very careful about parentheses and doing things in order. So anything in parentheses has to be carried out first. So in this example, we would do I cross J first, and then cross the result of that with I again. So I hat cross J hat. Let's see. I hat to the right, J hat towards the top of the page. Thumb points in the K hat direction. So I hat cross J hat is K hat. And now we're going to do K hat crossed with the I hat. So K hat straight out. My palm needs to be towards I hat. Let's see. K hat out, palm towards I hat. K hat crossed with I hat points in the plus J hat direction. So plus J hat is the result there. You try those two. Pause the video, work them out now. You got it? Great. Here we have, first do J hat cross I hat, which should be in the negative K hat direction. So then I hat crossed with the negative K hat direction. Okay. I hat, fingertips with I hat, but my palm should point in the negative K hat direction. Okay. I hat palm towards negative k hat. So fingers from I hat curl towards negative k hat. Thumb points in the plus j hat direction. Plus j hat right there. Last one, I hat cross j hat. That's in parentheses. That needs to be done first. We know that that is k hat. So this becomes I hat crossed with k hat, which will be negative j hat. Last example. Here we're given two vectors in terms of their components. Vector A is 3i hat minus j hat. Vector B is 2i hat plus 3j hat minus k hat. We want to determine the new vector A cross B. We'd write that like this. Here's vector A crossed with vector B, and let's apply the distributive property up here. We're going to distribute these terms across these terms. So first, we'll get 3i hat crossed with 2i hat, then plus 3i hat crossed with 3j hat, then plus 3i hat crossed with negative k hat. That looks like these three terms here. And then we're going to take the negative j hat and cross it with these three terms. So negative j hat crossed with 2i hat, plus negative j hat crossed with 3j hat, plus negative j hat crossed with negative k hat. There. Okay, you finish it up from there. Simplify these terms and combine until we get just an x component, a y component, and a z component. Pause the video, finish working that out. Ready? Here we go. Answer is the I hat cross I hat term is 0. The j hat cross j hat term is also 0. I hat cross j hat gives us k hat, so it's a 9k hat there. This negative 3 I hat cross k hat gives us a plus 3 j hat. The negative 2 j hat cross I hat gives us a plus 2 k hat, and the j hat cross k hat gives us an I hat. Combining terms, 9k hat plus 2k hat is 11k hat. So final answer, A cross B equals I hat plus 3j hat plus 11k hat.